Hello, just wanted to give you guys a quick example. I picked out one of the projects from one of your classmates, social media survey, just to let you kind of know what I'm looking for as far as the inferential statistic goes. So the first thing you want to do is a scatter plot of two numeric variables. So I'm going to look at the number of hours on social media and the number of hours studying over here. And you're going to go to Stat, Regression, Simple Linear Regression. Pick the one variable for your x variable, the other one for your y variable, and then over here we're going to perform a hypothesis test. Our hypothesis test is that the slope is equal to 0 and the alternate would be not equal to 0. We're also going to click on the fitted line plot, and then we're going to compute it. Over here we have our dependent variable is the number of hours studying, where the independent variable is the number of hours on social media. So we're looking at how does the number of social media affect the number of hours spent studying. And you could have certainly reversed those two variables if you wanted to. Over here's our regression equation. This is our correlation coefficient. It is 0.102, so pretty weak linear correlation. When we look at our test statistic, we're going to look at the slope down here. It has a test statistic, a t of 0.553. That corresponds to a very large p-value of 0.5844. And when the p is greater than 0.05, we're going to fail to reject the null. And the null was that there's no significant linear correlation. The next thing we look at is that fitted line plot. So this is our scatter plot with the line through it. Regardless of whether we have significant linear correlation or not, we can graph this, but we definitely wouldn't want to use this line to make predictions, as we've just shown that there's no significant linear correlation. The next thing we're going to look at is doing a regular test, and I am going to look at the following data. We're going to look at the number of hours on social media, and we're going to compare the males and the females. So we will first look at the summary stats. Over here, summary stats, columns. We are going to do the number of hours on social media, and we're going to group it by gender. So this allows you to kind of compare two different groups. Over here is our summary stats. There's 16 females with a mean of 18.06 and a standard deviation of 9.35. There's 15 male with a mean of 10.07 and a standard deviation of 13.31. And already we can see it looks like the males are less on social media than the females. So the females have a larger mean value than the males. So this is going to be our mu1, this is going to be our mu2. We will compare those, and the way we do it, we go to stats, t-stats. We have two samples with summary that we're comparing. Our first sample mean was 18.06. Our first standard deviation was 9.35. Our sample size for the females was 16. Our sample mean for the males is 10.07. The standard deviation is 13.31. And our sample size for the males is 15. We are doing a hypothesis test where the null hypothesis is that mu1 is equal to mu2, and our alternate hypothesis is that mu1, the mean time of the females, is greater than mu2, and therefore the difference of those two is going to be greater than 0. The last thing we're clicking is the p-value plot, and we are computing it over here. Our test statistic is 1.922 with a p-value of 0.033. This p-value is less than 0.05, therefore we're going to reject the null, and therefore we are going to say that our sample data support the claim that mu1 is greater than mu2. In fact, it looks like women are more on social media on average than men. Over here, when you go to the right, this is the p-value plot, which is just a nice little graph to include as well.